Hey, hi YouTube, hi everyone. In this video, we are going to explore about polymorphism. Till now, we have covered a lot of things in this playlist: class, object, access specifier, constructor, method, encapsulation, inheritance. So maybe you can go to the playlist and check out all this video. So now let's come back to polymorphism, and all this code will be also available in the GitHub repo. I will share it in the description box. So what actually polymorphism is? Polymorphism means, in simple terms, you can say one name, many forms. So the ability of an object to take on many forms. Like let's suppose we have a method called pay. Now, depending upon the object, the pay can work differently. Okay, the same method name can behave differently depending upon the class and objects is called as polymorphism. I will show you with some examples. Um, to show, maybe we can just move to the first polymorphism, which is runtime polymorphism, or we call it as method overriding. Okay, method overriding, or we also call it as runtime polymorphism. Okay, runtime polymorphism. We also call it as dynamic polymorphism. Okay, so method overriding means when we have a child class which redefines a method of the parent class. What actually you can say, maybe what is runtime polymorphism? Like a method to be executed, or the execution is to be decided while the program is running at the runtime. We call it as runtime polymorphism. Method overriding is an example of runtime polymorphism. Now, let me explain you what is method overriding. Already we have seen the definition, but let's suppose we have a payment class, and in payment class we have a method. Okay, let's suppose we have a method as uh, pay, because uh, all the payment methods will definitely have a definition, or have a all the payment class basically will have a pay method. Okay, so let's suppose we have self and amount. Okay, so let's suppose we have self and amount, and this will just print, I can say, paying paying amount with generic method. I'm just trying to give you an example. Okay, let's suppose we have a payment method as UPI, and we have already seen how we can inherit. So this is the way we are extending or inheriting the payment method, because UPI will also have pay, and maybe card will also have pay. So again, we are using the same method. This is what overriding is. We are overriding the method which is in payment base method, base class. We have a print method here, and again we can say here is uh, sorry, uh, paying whatever amount we have. Okay, amount via UPI. Okay, then we can have one more class. Let's suppose we have another class, and that class is basically card, and it will also have a pay method, and we are saying paying this amount via card. Now let's suppose I create P1, and P1 is, let's suppose, for UPI. I have P2. P2 is for again UPI. I have to run both these things, so maybe I can do like payment in both the things, P1 and P2. And what I can do is payment dot we have pay method. Okay, so let me just run it once. Okay, position one was okay. We have to pass some amounts. Okay, so let me just run it again. See, paying 100 via UPI, paying 100 via card. Sorry, it should be card class now. Okay, let me just clear it. Okay, paying 100 via UPI and paying 100 via card. It means that the same method pay is behaving differently depending upon the class or object that is calling. So if P1 is calling, which is an object of UPI, so it is printing as paying 100 via UPI. If P2, which is of card class, is calling pay, then it is behaving differently. So that is what polymorphism is. The same method can, the execution of the same method can vary depending upon the class or object that is calling. Okay, same name but different form. And this is an example of method overriding. Now, let's see about method overloading, because This is also a important part. Okay, so let's see about method overloading. Method overloading is also known as compile time polymorphism. We also call it as static polymorphism. So let me just write it something here so that it can be helpful for you when you will see the code. So now the next thing we are going to say is method overloading, and method overloading is also called as compile time polymorphism, or we also call it as static. Okay, static polymorphism. So what actually this method overloading is, like in some languages like C++, Java, you can define multiple methods with the same name but different parameters inside the same class. Okay, then the compiler decides which methods to be called based on the number of or types of arguments. But Python doesn't like supports traditional method overloading. If you write two methods with the same name, the last one overrides the earlier ones in Python. Let me show you. Okay, what I want to say is, um, if let's suppose we have a class as math util. Okay, sorry, math util, and we have a function like add. Now, if I add self a comma b and I'm saying return a plus b, okay, because we are passing a and b. Now we have another method as add which is taking self a b a comma b, sorry, a comma b comma c. Now it should return a comma b comma c. Return a plus b plus c. Okay, that's it. Now if I just create a object like math util and I do m dot add and I pass 10 and 20. So will it work? Let's see, will it work or not? So I got like my add missing one required positional argument C. Why? Because I already told you that it will always, like in Python, method overloading never works like that. Okay, it always consider the last one that is overridden. So here see, uh, first we write this definition of add, but what is the latest one? This is the latest one. So it will always refer to this. That's why it is saying C is missing. So if I add one parameter here like this, it should start working and the result should be 50 plus 10, 60. Sorry. See. Uh, oh, we have to also print it, na? Because all the things we are getting as a return statement. See, we got 60. So it just refer to the last one. So this is not a good way because in no, I can't say it is not a good or bad way, but in C++ and Java, sorry, in C++ and Java, um, you can also do like this. Okay, if this will also a valid thing because uh, true method overloading exists in case of Java and C++ and other languages. It at the compile time it binds which function need to be called. Okay, but in Python this type of things doesn't exist. So what we can do, how we can make it execute is using some default arguments. Okay, we can make some arguments default. Okay, if C is not passed, then maybe we can add 0. Okay, so now if even if 10 and 20 will also work. See, we got 30 because C is default. This is one way. Okay, what can be another way? Another way can be we can use args. Okay, variable arguments, I guess you already know about it. So what we can do is def add self, and let's take some arguments, and we can what we can do is return sum of or whatever arguments we are passing. Why we do args? When we don't know how many arguments we have to pass, how many variable arguments we have to pass. Quarks is when we don't know how many keyword arguments we have to pass. Okay, so in this case it is args. So now if I will run it, sorry, this is a function. Okay, now if I will run it, I'm getting 30. If I do it for 10, 20, 30, still it should work, I guess. We are getting 60. So this is a way you can also use method overloading. Also one another way is which is single dispatch or single dispatch method, but I don't want to cover it. It will become more complex. Maybe in some another video I can also explain you about how method overloading is added using single dispatch and single dispatch method also. Generally, I haven't seen in my career till now single dispatch method in the production or in the app development. maybe it would be used, but I haven't seen that much, so that's why I'm not covering here, because the video will also become large, and at the beginner level, even if you ever don't know about it, definitely knowing everything is good, so you can explore on your own, because but the video will be very long, so that's why I'm not including it. Okay, so this is about method overloading. Now similarly, we can also have, sorry, I don't want to review or override AI. So now we are going to have operator overloading. Okay, operator overloading. Okay, so operator overloading means when, let's suppose we have an operator and we want to overload it. Okay, so let me show you. Print 10 plus 20. Okay, so this should work. Print two maybe 10, uh, sorry, 10 plus 20. Okay, 10 plus 20. I think. Okay, good. See, now if I will run it, what I will get? 30 and 10, 20, because first one is integer addition, second one is string concatenation. But let's suppose I have a complex number. What complex number is, let's suppose I have 10 and 20, and another complex number I have as 20 and 30. Now, if I want to add it, what should be the result? It should be the I elements or the x elements, which is 10 and 20, should be added, and it should give me 30, and the last j or y element, which is 10, 20, and 30, it should add and it should give me 50. Might You might have also seen it in complex numbers like 10i plus 20j, 20i plus 30j, it gives us 30i plus 50j. So if we have to perform such kind of operations, then we have to modify our operators, because currently operators can only support this thing. Either it can add two integers or two decimals and or two string, but it is also a concatenation. So this type of things we can, if we have to overload the original operator, we should use operator overloading. Let's suppose we are creating a class vector where we want to support that kind of addition. So what we can do is we can have a init to have a constructor, because if we have to do I if we have to add complex number, it has two parameters. So one is x, and let's suppose another one is y. Okay, self dot x is equals to, sorry, self dot x is equals to x, and self dot, sorry, self dot self dot y is equals to y. Okay, now definitely I have to overload the add, or override actually the add operator. So it, let's suppose we have other. Okay, actually other is also type of vector. Okay, I will explain you, because without code explaining it, it is a bit tough for you to understand vector. And let's suppose we have self dot x plus other dot x, then comma self dot y plus, sorry, self dot y plus other dot y. Okay, we, this is how we are adding it. So also we want a string representation of it, which is basically string representations are a way of representing your object, because vector class, how the, whenever you will create an object of vector, how it will look like. Okay, if you will not have a string representation, it will just return the address of it. So return maybe a string, and it is saying, let's suppose we have uh, there are two things, self dot x and we have self dot y. Self dot y. Okay, now let's suppose I created two vectors, v1 vector, I have 10, and no, sorry, not 10, it will have two things now. So let's suppose we have 2 comma 3, 2 2 comma 3, because it in it also you can see we have to pass two things. Okay, then we have v2 will be vector, let's suppose we have 4 comma 5. Okay, now if I do print v1 plus v2, we should get again a complex number. So see here what we are getting. Sorry, I should just, okay. Maybe what I can do is print uh, number one. Number one is basically v1, because we already have created a string representation. Number two is this one, and last one is result is the self understood. Okay, see. Number one is 2 comma 3 and number two is 4 comma 5, and when we are adding it, so 4 plus 2 6 and 3 plus 5 is 8. So this is how we are creating our own addition method, or you can say we are overriding the overloading the existing add method. Okay, see how this is basically working. So we have magic functions. You can have a lot of magic functions like subtract for subtraction, add for addition, and whatnot. So we are passing a vector. Try to understand it. We are passing a vector. So whenever we are doing it, v1 plus v2, try to think like it is like this. v1 dot, it is calling an add object and it is passing v2. So v1 is the object itself that we are passing. So this object can be accessed by self, and v2 is what we are passing as an object. So it is other. So if we are accessing self.x, so we are accessing v1.x. What is v1.x? 2. Then what is other? This what we are passing. v2 is getting accepted as other. So what is other.x? It is v2. Sorry, it is yeah, it is v2.x because it is other. We are passing it. So v2.x is 4. So self dot sorry self.x was 2 and other.x is 4. So 4 plus 2 is 6, that you can see it here. Similarly, v1 dot add v2 and v1 is passing as self. So what will be self dot y? v1 dot y. What is v1 dot y? 3. Then we are passing v2 and it is getting accepted as other. So other dot y. What is other dot y? v2 dot y. What is v2 dot y? 5. So 3 plus 5, it is we are getting as 8. So this is what how we can see about operator overloading. Similarly, you can try to overload some other methods. We have also some methods for subtraction. I guess this is what a method subtraction. If you want to overload a subtraction method, it will look like this. So maybe you can also try this. There are multiple magic methods. We are definitely going to have another video, but this is how we can overload some operators. Okay. Mostly in my journey till now, I have seen a lot of applications of method overriding. Okay, this is really important. Dynamic type polymorphism and runtime polymorphism. Generally, abstract class and this method overriding are heavily used even in patterns as well as in coding practices. So you should know about it in a very better manner. Okay, static. Sorry. The abstract class and all we are going to see in abstraction video, which is going to be the next video. Okay, can we have a real world example of it? Yeah, definitely. Let's see. We can have a real world example for it. Let's suppose we have a class called shape. Okay, so shape can have definitely area method. Okay, and so I'm just adding pass here. Sorry. So now class circle. So circle, if we write the init of circle, it will take a we can say radius. Okay, so I am calling it as r. So self dot r is equals to r, and definitely this circle is a shape, so it should inherit the shape. We have already seen it in the inheritance video. Now it will also have area. It will take self, and it will not take anything actually. So it will just return. So return what is the area of circle, pi r square. So 3.14 multiplied by r multiplied by r. Okay, that's all. So what is happening? Yeah, self dot r, sorry, self dot r multiplied by self dot r. Okay, then class we have, let's suppose we have rectangle. Okay, this should also be inherited from shape because it is the relationship. Rectangle is also a shape, circle is also a shape. Okay, so def init, we can say self, it will take length and breadth both. So I can say self dot L is equals to L and self dot B is equals to B. We have def area, and what is the area of rectangle? Length into breadth, I guess. So length, sorry, self dot L multiplied by self dot B. Okay. We are done, I guess. So let's suppose we have created a shape one which is of circle, and let's suppose the radius is 5. We have shape 2. Shape 2 is, or let's suppose, of rectangle, and the length and breadth is 10 comma 20. Now if I do shape 1 dot area, it should call the method of the area method of circle. And if I call shape 2 dot area, it should call the area method of rectangle. Okay, so just let me just clear it a bit. See, 78.5 and we are getting 200. It means that we have the same name. Area is the same name. It's same everywhere, but the forms are different based on the object. So shape one is of circle object, so it will call the method of circle. If shape 2 is of rectangle type, so whenever we will call area, it will call the method of rectangle. Okay, so that's it. So in this video we have seen a lot of things. First of all, we have seen method overriding, highly important, and it is combined with you can say abstract class. Then we have seen method overloading, which is a compile time polymorphism, static type polymorphism. We have also seen how it is not a true method overloading in case of Python, but we generally you can say we try to achieve it using default arguments or args, or there is one more thing that I already told you, that it is we can also use some kind of single dispatch method, but I'm not covering it. Maybe I can cover it in another video. Then we have also seen method overloading. You can try for subtraction, we have done for addition, and we have also seen a real world example. So that's it in polymorphism. In the next video we are going to see definitely abstraction, which is really important, and that will be the last pillar of OOPS. So that's it. Meet you in the next video. I hope you have enjoyed it, and if you like this video, please consider subscribing and liking, so that I will get more motivation to build more videos. And if you have any doubt, let me know in the comment section. I will definitely be there to help you. Thank you. Have a great day.